So that pretty much brings us to the end of our discussion of cloud, of looking at the terms and definitions which describe cloud. And I hope through this process and through this course that you've got a much better sense of the different characteristics and the service models that make up cloud. And let's have a bit of a recap. We talked about the service models. We talked about software as a service, where you go and consume typically a web application which is entirely managed by somebody else. We've talked about platform as a service, where we are deploying just the application and then everything else is managed by somebody else, and how these things are all really continuum which end off in infrastructure as a service. And so we had a continuum between the lot. Infrastructure as a service being where you get most control and you can deploy servers with your own applications and your own integration potentially, these types of things. So those were our service models that we discussed. We then talked about our 5 essential characteristics of the cloud. And if you're going through the NIST paper, this is the first thing they talk about. And we talked about on-demand self-service, so how everything's automated. And we talked about our person with the admin console who goes through to an automation process to be able to get their cloud resources. You know, they're not sitting there on the phone to Bob, and Bob's not on the phone to Sam, and it's not all a mass of people that are going around and doing stuff. It's all automated. I mean, in the background at Amazon Web Services, they have their own equivalent of Sam, but you never need to know they're there, and you never need to talk to them. And essentially, you never need to talk to an account manager, although no doubt they would like to talk to you from time to time. We talked about broad network access, how essentially you can connect to it through the internet, and that's pretty much all it is. Lots of people are going to tell you it's more complicated than that, but that's pretty much all it is. We talked about resource pooling, so the provider there masses together their economies of scale, so they've got an enormous pool of resources that can be sliced out just to you and to other people through a multi-tenanted model, so you get your own little slice of what they have to offer. But it's in a location which is independent of you, and you don't necessarily know where it is. You might be able to define it down to a region of the world, but that's all you need to know, and pretty much that's only for compliance purposes. So it's location independent. It's somewhere else. We talked about the other characteristic of rapid elasticity. So your application can scale up and scale down on demand. You only pay for what you use in that model. So if you scale up to 17 servers and you only use them for an hour, and then you scale back down to 1, then you only pay for those 17 servers for 1 hour, and then you're back to paying for 1 server. Back to this automation, back to on-demand self-service, I suppose, within that realm. And we talked finally in those essential characteristics about measured service. So you can see what's going on, the provider can see what's going on, they can bill you appropriately, but you can also use those metrics to control and maybe add into the automation process to be able to make use out of rapid elasticity, scale up and scale down based on not your ideas or what time of day it is, but how busy your application is. And finally, we talked about the deployment models. And we talked about primarily, I'm going to say, the difference between private cloud and public cloud. And here we go. We got our silk ropes, what are they? The velvet ropes, sorry, which is cordoning off our wonderful private cloud. You can't get to it unless you've got a special invitation. And here we go with our public cloud. And that's everyone can get in here. There's our signpost. That's what that's supposed to be. I'm getting towards the end of the course. I'm having fun here. And so you have the difference between our private and our public. And the difference is how you buy it. At the end of the day, the same kind of thing should be behind there, but in private, you only get to it if it's part of your organization. It's a procurement construct only. So that's it. That's the end of the course. I hope you've had I hope you've had fun. I hope you've taken away something from this course, and I hope it's been useful. I really would appreciate your feedback. Tell me what you liked. Tell me what you didn't like. I'm going to iterate through the style in which I put these presentations and videos and tutorials together. So please do tell other people, especially if they've got an interest in cloud, especially if you've had one of those conversations with them already where they're saying, there's no such thing as cloud, it's just a computer in someone else's data center. Well, now you know different, and now you have a way to respond to them. Tell them to come and see this course, and we'll put them right. So please leave some feedback, please leave me a review, and I look forward to seeing you in the next course. So as with all great instructional videos and instructional courses which it claims to tell you what something means, we start off with saying what it doesn't mean. And cloud computing is not a buzzword. That's a really important point to get across. We need to get away from the hype. We need to get away from the marketing terms. Who remembers things like Web 2.0? Now that was a buzzword. It didn't really mean anything. There were definitions of it on the internet. You'll still find some today. I'm sure Wikipedia says something. O'Reilly said something else. It meant something to do with websites that were interactive and contained, I don't know, Ajax and the like. But it didn't really mean one particular thing. You couldn't hang your hat on one definition. I don't know if anyone's ever heard of Web 3.0. I'm sure someone's trying to coin that phrase, but it's not a thing. Okay, these are buzzwords. We know that. Marketing terms, they're useful if that's what you need them to do. A marketing group will use it for promoting their product and sort of putting it into some perspective. And you can kind of get the idea, but it's not actually defined. You can't go and buy a Web 2.0. Okay, the other one, I mean, the thing of the moment, Internet of Things, another buzzword. It's an interesting one. It's a lot of hype around it at the moment, but it means a lot of things to different people, and companies are finding the products that they've always done, been doing for the last 10 years, and actually that's Internet of Things. Yeah, come and buy us. Pump all your data from your windscreen wipers into some big data solution. Big data, there you go. There's another buzzword. Cloud is not a buzzword. Cloud computing is not a buzzword. I've seen things written in where was it? There was a rec room in somewhere I was working. It had a poster up there, and it said there is no such thing as cloud computing. It's just a computer in someone else's data center. No, that really isn't what it is. We'll see that in a lot more detail as we go through the subsequent lessons of this course. But we're going to be far better positioned than the people that put that poster up. It's not a buzzword, and it's not just a fad. Let's look at it here in a bit more detail. What we'll do is we'll look at the foundation basically for this course. And that is the National Institute of Standards and Technology, or NIST, and they have put together a cloud definition. I'm just going to put that in Google, as you can see, and here, top result is a PDF. If we click on that, we get the actual document itself. It's a pretty short document. There's not awful lot to it. It's like 4 pages in total, and I think a couple of them are the introduction. There's really only 2 pages which have the nuts and bolts of the actual definition of cloud computing. And here they are. They split them out into essential characteristics, service models, and deployment models, as I spoke about in the introduction. And so this is the document that we'll be using to go through the definition of cloud. We'll look at each of these sections in turn, but we'll put them in a bit of context. So I just wanted to show you that. Now, there's no need to go away and Google this right now and read it. Of course, you're welcome to. If you want to pause this course, go and have a look at it. But we'll be using this document as a sort of foundation and a glue, if you like, to the subsequent sections of this course. So let's take a look at service models for cloud. And if we go back to the NIST paper that we had before, the National Institute of Standards and Technology definition of cloud, that we discovered this paper during the It's Not a Buzzword lesson. And if we scroll down, we'll go through each section and we'll find there is the service models here. And as we spoke about before, you'll probably remember, or you may already know some of these terms: software as a service, platform as a service, and infrastructure as a service. And so that's what we're going to go through now. Now, to do that, there's a very helpful diagram or set of diagrams which we can find. And I'm just going to go and Google for that now. So if you have a look for software as a service versus platform as a service versus infrastructure as a service, and we go to Google image search, then here we go. You'll notice there's lots of these, and here's one attributed to Microsoft, so that's pretty useful, and we'll take a look at it. So what we'll use to be able to differentiate the different kinds of platforms that we have in the cloud is this stack model here. Now, if you've studied IT at university or somewhere like that, you might sort of recognize this. This is a bit like the OSI model, but it's not quite the same. But it is a top-down view of a stack of a IT system. And it starts with applications and goes all the way down to networking. So applications, these are fairly obvious, I suppose. These are things that we install and we use as users of a system. The data, so we're talking databases. Runtime, so we're talking things in here like Java or .NET. Middleware, messaging systems, these types of things, maybe a service bus. Operating systems, so your Windows or Linux, Oracle. The virtualization layer, so if our operating systems are virtualized away from servers, we'll need a virtualization layer, and in a traditional IT environment we're talking about VMware, that type of thing. They sit on top of servers. These are physical servers, the boxes with flashing lights that we see. Storage, those are the other boxes with other flashing lights but that usually contain disks. And then finally the networking, so we're plugging cables in and out and we're actually routing data around. And so if we consider this model here, we can actually use this to look at and describe the service models of cloud. So the first of the cloud service models we'll look at is infrastructure as a service, and that's shown to us here as IaaS in this model. And if we remember this stack from the previous lesson, this gives us a context which we can use to describe what infrastructure as a service provides for us. Now the blue in this diagram here represents the things that you manage, and the grey represents the things that are delivered as part of the service from the provider. So a great example of infrastructure as a service is AWS, Amazon Web Services, and of course you've also got Azure from Microsoft. There are others too. You've got Rackspace and what have you, but these are basically the two leaders in this field. So what do they provide you? When you go to AWS and you buy some infrastructure as a service, what do you get? Well, you get the networking, storage, the servers and the virtualization all the way up to part of the operating system. You get all of that provided for you. And basically what that means then is that you're going to get the data center. You're going to get the data center all the way up to a virtualized machine which you can do something with. So if what you need is a Windows machine, for example, that you can remote desktop into, but you don't care where it is because it's in the cloud, then you can go to AWS, you can provision yourself a virtual machine, and you're ready. You can deploy whatever you want on top of that. And what you're going to deploy on top of that is some, well, I'm going to say operating system management you'll have to do. So your antivirus, potentially your backups and things like that, you'll have to handle. Middleware if you need it. Runtime, so if you're going to install a Java runtime, for example, on there for your application. Data, so if you need a database, you can go and create one. So you might want to spin up another virtual machine to install a database on that machine and connect these things together. And then finally you'll deploy an application on top, something to actually make use of the capabilities of the environment. And that's infrastructure as a service. You deploy the application all the way down to the operating system management, and the rest is provided for you. And you don't get to play in this space. This is the actual physical data center. This is the actual servers and the disks. They handle all this for you. You don't have to deal with this. Now, Amazon have a couple of great marketing terms, but one of them I like in particular is undifferentiated heavy lifting. And what they're saying here is that we do all of the stuff that basically everybody does. You handle all the stuff on top of that which differentiates you. So we do all the undifferentiated heavy lifting. You go and do the bit which makes you different from your competitors and the bit which differentiates you in the marketplace. And this is where you add value. They're saying, why do you bother racking servers in a server room? Why do you bother plugging a network cable in? That doesn't make you different from any other enterprise. Go and do the bit on top of that which actually adds value and makes money. And that's infrastructure as a service. Now let's talk about platform as a service. And you'll notice what's happening here. The blue section, the part that you manage, is much smaller now than the grey section, which is what the service provider manages. And so now what's happening is the service provider is looking after the whole of the operating system and is handling patch management and backups and those types of things for you. They're also potentially handling any middleware that you need and runtime that you need. So it's just a case of you coming along and adding your application and data. Now, what does this actually look like? When we talked about infrastructure as a service, we talked about Amazon Web Services. And I talked about it in terms of how you could provision a virtual machine and deploy a workload and off you go. Now, if you've taken any look at Amazon Web Services at all, you'll know that there's lots more services in there than purely a virtual machine, or what they call EC2. There are lots of other services such as managed databases, managed message queues, managed storage, which you can use. And Azure has a similar kind of lineup of products as well. And these things fit into the platform as a service mold. So for example, if you look at the managed database service that AWS provide, they will allow you to configure a environment in which has an Oracle database, for example, where they will deal with a lot of the day-to-day running of an Oracle stack. So you don't have to look after the operating system, and you don't have to look after patch management of the actual Oracle database itself. So we'll call that the runtime. You just have to go on there and implement your own data schemas, your own stored procedures, whatever it is that you want to host inside of that Oracle platform. So you only manage the bit which sits on top. And this is a view into what happens in cloud, is that there is no vendor that I can think of that will isolate a product or a product suite to only one of these sections, not to only infrastructure as a service or to only platform as a service. So Amazon is a great example of something that blends across the two. And that's platform as a service. Now let's take a look at software as a service. And you'll notice here, of course, that there is no blue at all. The entire stack is managed by the service provider. Now, that doesn't mean to say that you don't have your own space in there. It is still going to be a multi-tenanted environment where you can have your own data. A great example of software as a service, and one that's very much in the public domain, so it's very accessible to people, is Gmail. Gmail is a complete service provision. The application is deployed to a server somewhere. You have no concept of it. You cannot update it. You cannot change it. The data in the database, all of it, all the way down to the networking. I mean, it's somewhere else. We have absolutely no concept of where it is, unless I suppose you work at Google. But that doesn't mean to say that you can see everybody's email. When you sign into your account, you see your email. So you are able to get a multi-tenanted slice of the software as a service product. So that's key and important to understand. You can still do some level of configuration, but the entire stack is managed by somebody else. That's software as a service. So to compare these models, let's just recap. We have infrastructure as a service, platform as a service, and software as a service. And we talked about some examples of products that fit here. So Amazon Web Services absolutely fits in the infrastructure as a service realm, but it also fits over into platform. No question about that. Software as a service, we talked about Gmail. And I suppose in many regards that really is software as a service. That doesn't really go anywhere else. Let's have a look at Salesforce.com. Now, this is a quite fairly famous, it's one of the first software as a service platforms really to emerge. And it's a software as a service CRM, so customer relationship management system. And it definitely sits in the software as a service realm. If you want a CRM and the software as a service product from Salesforce meets your requirements, then go for it, sign up, you've got it, you're done, you have a software as a service solution. But Salesforce has also branched out into other areas, so you can actually upload some fairly sophisticated configuration, which really borderlines on an actual application. You can certainly model data inside of Salesforce, and so this then also spreads itself down into platform as a service. And this is what we talked about somewhat in the previous lessons, but all of these things really, all the infrastructure, platform and software as a service, they sit on a continuum. And there is a definition for what each of these stops means, but many products will fit in between here. Many products from many different providers. And so using these definitions, we can understand them all, but it's just important to realize that nothing necessarily fits black and white into each one of these buckets. And you'll find that the as a service title is used for various things in the marketplace. One I heard of fairly recently was integration as a service, and that's used by people to be able to describe the thing that they have, which is like a message bus, for example, but provided as a service. But it probably fits somewhere in the platform realm, maybe towards infrastructure, I don't know, maybe it fits around here. It's kind of subjective, you can decide where it fits, but understanding how these things fit together gives you a sense of where products sit on this overall continuum, and that probably helps you make the right kind of investment decisions or strategy decisions in your organization. The other thing I want to mention is investment profile. So if there is a product which sits in software as a service which matches your requirements, then it is likely that this is going to provide you best value for money. Think about it in comparison, think about it in relation, for example, to CRM. If you require a CRM and the Salesforce CRM meets your needs, if it does, then getting it from Salesforce is likely to be better value for money than if you were to make it yourself. And so your return on investment curve, if you like, between software as a service and infrastructure as a service looks something like this. Now, that's not to say that infrastructure as a service is bad. Infrastructure as a service is measurably better than, for example, on-prem or traditional IT, which will be somewhere off the side of the diagram, down in the diminishing returns of having lots of physical equipment on your shelves. But if you can find a software as a service product which meets your needs, my suggestion is go for it. But it is often the case, of course, that you're not going to be able to find something that exactly meets your needs. Maybe the thing that differentiates you from your competitors is the thing that you need to actually have installed in an application. So, of course, platform and infrastructure as a service is there to meet those needs as well. Okay, so essential characteristic number 1 is on-demand self-service. So let's go back to our NIST paper here, the NIST definition of cloud computing that we found before in the previous lesson. And let's go down to the section on essential characteristics. Here it is. And we'll look here at the first one. And as I said, it's on-demand self-service. Here it is. And I'll just read through it quickly, but then let's sort of pick out the key points and let's just discuss them in turn. So it says on-demand self-service, and it describes it as a consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each service provider. Okay, so it's talking about compute capabilities as we expect from a cloud service, and it's giving the example of server time and network storage, but this could easily be network service, it could be email service, or it could be some kind of integration service or some photo storing service, whatever it happens to be. And it's saying that it can be provisioned as needed automatically and without requiring human interaction. And so automatically here is probably one of the most interesting pieces. And let's take a look at that. So first of all, let's sort of consider what we might expect from a traditional computing environment before cloud computing came along, I suppose. You might expect to have in your state or your city or wherever a building with DC written more or less on the side of it. Of course, this is a data center. So you might have one in your organization, or you might use someone else's, like at a colo or something like this. And inside it, there are racks upon racks of things and computers and switches and network gear and all that kind of stuff. There's probably even some space in there where you could go and put your own stuff. And sat at the front of this organization somewhere is a desk. There it is. And behind the desk sits Bob, or some other person, smiling there. And on Bob's desk is a telephone, something like that. May also receive email, maybe, but you get the point that there is somebody fronting this organization, this data center. So you talk to Bob. There we go, Bob, if you want anything done. So you over in your organization, you want something done, well, you have to have a telephone too, or maybe email or whatever. And by using this kind of communication, you talk to Bob. Bob then talks to somebody who's working down here. So this is going to be Sam. And he talks to Sam, and he or she goes and works in the data center to do the thing you needed. But it might also talk to somebody else who goes and buys a piece of equipment that's necessary to do the thing that you wanted to do, to give it to Sam to put into there. You might even send some of your own equipment in and say, hey, please rack this thing for me, and I'll buy that service from you probably a year at a time. This is typical kind of data center stuff, typical kind of co-location stuff. And this is not cloud. There's nothing very on-demand about this. For a start, Bob's at the center of everything, probably an account manager, you need to talk to them. And things are not very automated here. Certainly some of these places have set up, websites, and maybe you can go into the website and click the OK button. But if the essential path is the same, then we're not very automatic. So things tend to run for a very long time. You have contracts that run for a year at a time, maybe because they have to go, and this person down here is going off and buying a piece of hardware. They can't just and dedicating it to you in the data center. That's how it works. So you call them up and say, I need a new compute resource. No worries, we'll send someone off to go and buy it. We've bought it now. It'll cost you this much. We'll split it up over the next 2 years, but you've got to be with us for 2 years, otherwise we're going to charge you some sort of exit fee. Traditional kind of stuff. This is the kind of stuff we deal with, but this is not cloud. So in cloud, when we're talking about on-demand self-service, well, I guess it kind of speaks for itself somewhat, but we talked about the automatic provisioning and that kind of stuff. So here's cloud now. In fact, why have I drawn it like that? I suppose we should really be talking in terms of here is cloud now. There is actually a cloud. Architects have been drawing clouds on diagrams for a long time, maybe before we even really started talking about cloud computing. And a cloud represented a whole set of things, and inside of that cloud, it's very complex stuff, and I don't really care what it is, and I'm going to interact with it from the outside world. We've always drawn clouds like that, and that really is what cloud is. I don't care what's inside. I just know what I want, and I need you to provide it to me. Anyway, so we've got ourselves a cloud there, and what we are going to do is we're going to have the same person on our side of the fence, but they're going to, in the first instance, let's give them a console with an OK button. And when they press that OK button, there is a process that runs here, and that process then works on cloud things for us. That's one way it might work. It might also be that over here we have a command line, and there's an API associated with that, for example, or CLI, whatever you want, a command line interface or an API. And I suppose an API would be I have my own application that I've done with my own OK button. And this person at our place can do any of these things, and all of these things communicate with a process layer, which then goes and does something in the cloud. Something else that might happen is that the workload I have here might itself go and talk to that process. And it might say, hey, you know what, I'm running out of resources, I need some more stuff. And it might then go back in here and provision more stuff. and we'll certainly look at ways that that works when we're looking at infrastructure as a service, for example. And in this stuff, I mean, if in infrastructure as a service world, this is going to be completely transparent. The fact that this is this will be configured by us. The fact that it's doing this, going back to this process model and saying going around and organizing itself. In the software as a service world, this kind of stuff would be completely transparent. We don't need to know how hard the infrastructure is working because we're just using it. And so yeah, you've got that's our admin bod sitting there working on all that kind of stuff with the consoles, and we have our users who are accessing this stuff, and they're none the wiser really. Okay, so that's the cloud setup for on-demand self-service. We can go without having to call up Bob, the account manager, without Bob then having to call up Sam to go and do something. Without any of those things, automation is at the key of it. And this is really one massive automation process which sits covering the whole of the cloud infrastructure and will manage the infrastructure in the cloud without us having to go and actually do something ourselves, and without Bob having to go and do something themselves. It all is automated. So the second essential characteristic of a cloud service is broad network access. So if we jump back to our NIST paper for a second and just take a look at that, here it is. I kind of like this one because it's really straightforward. And if you have done any other courses, and if you've read any other documentation, or if you choose to do so after this, you'll find that a lot of places really butcher this because they want to make it sound way more complicated than it really is. It's actually really straightforward, and I suppose some of it is to do with the language used when they define this one. But it says broad network access capabilities are available over the network and accessed through standard mechanisms that promote use by heterogeneous thick or thin client platforms, e.g. mobile phones, tablets, laptops and workstations. So what does this mean? Well, as I said, it's really quite straightforward, and it's nothing like as complicated as some people might make you believe. It basically means over the network. These things are networked together. You can't get access to cloud computing unless you're connected to some network. The cloud platform is going to be somewhere else. It's not going to be in your own sphere necessarily, unless it's potentially private cloud, but even then it's going to be somewhere else, and you need to connect over the network. That's about as straightforward as it is. They start to talk in here about heterogeneous thick or thin client platforms. In other words, everything: mobile phones, tablets, laptops, and workstations. Sure. So if we even wanted to draw a picture of this, it's fairly straightforward stuff. There is a cloud, there is stuff on it, and we connect to it through a network. You could get a little bit more sophisticated than that, I suppose, and start to talk about the fact that this network is a standards-based network. So it has to be a network that we're able to communicate with. And so, of course, we use the internet, we use TCP/IP, we use these types of things. We use very well-known and well-understood web-based services, typically to connect to this stuff. And sure, off of this, we can have a whole host of devices. And of course, these days, desktop laptops, mobile phones, they're kind of all the same thing anyway. I mean, most of iPhone, MacBook and iMac, they pretty much all run on the same kind of operating system anyway. So it's really not that complicated. We can talk about how the cloud service provider might use various APIs and various libraries in order to connect to it. That could be included in here as well. But it's really not very complicated. It's that you can connect to cloud over a network. As I say, you'll go through plenty of other documentation that you may choose to read. We'll try and go into this in a lot more detail, but essentially it doesn't mean anything more than that. Next up in our essential characteristics is resource pooling. And this one's quite a good one, quite a meaty one. Resource pooling. The document says the provider's computing resources, so in this case it's the cloud computer provider, the provider's computing resources are pooled to serve multiple customers using a multi-tenanted model. with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. There is a sense of location independence in that the customer generally has no control or knowledge over the exact location of the provisioned resources. And it goes on to say that you might have some level of an idea by which country it's in, and it gives examples of storage, processing, and memory. So let's have a pick out of the key words there. So obviously with resource pooling, one of the key words is pooled. We see that it serves multiple consumers in a multi-tenanted model with different physical and virtual resources dynamically assigned, on demand. So this is back to on-demand self-service, no surprise there. There is a sense of location independence. This is quite important. And that the customer generally has no idea where the infrastructure is. But you might have some level of control over a higher level of extraction, so country, state, or data center. So let's go and take those key points back over to the blackboard. So this point draws together on a few of the topics, I suppose, that we've already looked at. So if you look at the resources that sit in the cloud provider, and this is the kind of diagram that we drew on the side when we were sort of pretending that a cloud provider was in a data center. And we look inside of here, it's got lots of genericized pieces of equipment for networking, for storage, for whatever it might happen to be. I suppose it applies just as easily to software as a service as well. So you could think of that as in terms of application units of some sort. And then over on this side here, we've got a user with a console, or a customer more to the point. So this would probably be someone in the admin space with a console. And let's get another one as well. And these two customers are entirely different organizations. So I'll draw a line between them. And this customer comes in through their console and they provision for themselves through their console a portion of the kit. And so the other customer comes along, I'll choose a different color, and they grab themselves other parts of the kit. Now, which parts of the kit have been allocated depend very much on the service provider, not the customer. So the flavor of it can be determined by the customer, but which particular bits of it are determined by the provider. And so they're taking it from their enormous pool of resources. Remember, we're talking here about resource pooling. And it said, remember, the customer's computing resources are pooled. So this is pooled into this massive yellow box we have here to serve multicolored customers in a multi-tenanted model. And so what we're showing here is that the two different customers have different slices of the same infrastructure, of the same pool. Now they're not able to see each other's data because one is only able to see blue and the other one's only able to see red. And so that's multi-tenanted. The other part of resource pooling, which was key there, was the location independence. And this is then really where it comes into me. I should really probably have drawn this in a big cloud. These people have no concept of where this is. Now, that being said, we also had that sort of caveat, if you like, that they might know roughly where it is. So a cloud provider and an infrastructure as a service provider is a typical one of this. Amazon Web Services will allow you to select which country or which side of the country potentially you want the services to be hosted from. But other than that, you really don't know where it is. So you might be able to choose it down to a city. So Amazon Web Services in Australia, for example, has a bunch of resource in Sydney. And technically speaking, we don't know where in Sydney that is, but we know it's in Sydney somewhere. So customers who are concerned about their data traveling overseas can know that by using the services in Sydney, they'll stay in Sydney. And the same can be said for Ireland, and the same can be said for Singapore when you're dealing with Azure and these types of things. So you can isolate it down to a country, but where it is in that particular country or maybe into the city, you don't have a say about where it goes. It goes to anywhere within the provider. And why do you need to know? And remembering, we don't want to go and touch these servers. We're paying someone else to look after it for us. I don't want to be able to walk in and touch the servers. I just want to be able to deploy my application remotely, or I just want to be able to use the software and not have to think about anything lower down in the stack. So that's resource pooling. So to recap, we have a massive pool of resources which are sliced out into a multi-tenanted model for the different customers, and those customers don't have any real sense of where that is. So certainly not which data center and certainly not which rack, but maybe which country. That's about it. Next up is rapid elasticity. And this is a pretty exciting one when it comes to the cloud. This is something that really traditional IT and on-premise IT can rarely do. And if it can do, it can't do it anything like the major cloud providers can. And what does the paper say about this? It says capabilities can be elastically provisioned and released, in some cases automatically, and I'm going to say in pretty much all cases automatically, to scale rapidly outward and inward commensurate with demand. To the consumer, the capabilities available for provisioning often appear unlimited and can be appropriated in any quantity at any time. That sounds almost magical, so let's demystify it a little bit. Capabilities can be elastically provisioned and released. So provisioned and released, I want to talk about. Some cases automatically. I think when we were talking about on-demand self-service, that really mandated automation, in my mind anyway. And this is to scale rapidly inward and outward. So you can scale up and you can scale down. Let's talk about what that means. And to the consumer, the capabilities available for provisioning often appear unlimited. That's pretty crazy, and can be appropriated in any quantity at any time. Now you combine together on-demand self-service with unlimited quantities, and interesting things start to happen. Let's take a look at it from the whiteboard's perspective. So if we take a look at one slice of what we were talking about that was involved in a cloud provider, and here we go, we've got the units of things. So this could be, again, networking and server infrastructure. It could be software units, whatever it is. It could be number of accounts, things like this. And over here we have a user, an admin user with their console. But we're going to add some other things in here as well. We're going to have, we're going to bring back the automated process that was sort of sat in between the console and the user and the cloud provider that we had before, which is managing what goes on in here. And the user is going to provision themselves a number of units that they need to run their application as far as they see it. Now, what the user can then do is sort of turn the knob up, if you like. So let's have their knob that they're going to turn up. In a virtual sense, they can crank that knob around and provision more when they feel like it. Rapid elasticity. I suppose the rapid part of this means that it has to happen automatically. In my mind, it happens not after a phone call to Bob and Sam and all those other people at the data center. It just happens. It could also be, if this was, for example, in an infrastructure as a service world, that these compute units could be reporting back to this automated process itself. And the automated process could be monitoring it and saying, hang on a sec, these are getting overworked. I need to scale up. And I need to go and grab some more. And what's happening here is that this admin person, you, sat over in this enterprise, is not jumping on the phone and saying to Bob, look, we're going to have a busy week next week. I'm really going to need to get some more capacity. Because with rapid elasticity and this essential characteristic as we have defined it, the capability of the service provider can appear unlimited. So what's happening here is that we have a mixture together of these other essential characteristics we've been looking at. Remember resource pooling. I mean, while you're scaling up your application, or while your own application is even scaling itself up, somebody else somewhere else may be scaling their application down. And so there is a spare capacity being released somewhere which you can then use up. And when you need to scale down again, you can scale down. You don't have to do anything special. You can just stop using it. And that then goes back into that resource pool that we talked about before. And so cloud computing organizations, cloud computing service providers have to play these numbers games of making sure they've got enough infrastructure there to cater for their projected growth, this type of thing. But for you, it appears unlimited because you just keep chewing away. And if you get to a point where they run out, they're going to have to buy some more and slap it in, and then you can keep chewing that up. But then you can scale back if you want to do so. And this then goes with how much you pay, because typically with a cloud provider, you pay for what you use. And so you pay, in this case, for this much. And then if you add on a whole bunch of resources, then you'll pay for that much. But then if you scale it back, your dollar spend will scale back too. And that's a real key element of how cloud works and how you can often drive great savings from cloud infrastructure. If your servers become less busy, you can turn some of them off and you can stop paying. So let's look at the last of the essential characteristics, and that's measured service. Here it is in the definition paper. And it goes to say, measured service. Cloud systems automatically control and optimize resource use by leveraging a metering capability at some level of abstraction appropriate to the type of service. And they give the examples of storage, processing, and bandwidth, but they also give the example of active user accounts, which relates to software as a service, which is a nod in that direction. It goes on to say resource usage can be monitored, controlled, and reported, providing transparency for both the provider and the consumer of the utilized service. And I think that's really the key bit here. Monitored, controlled, and reported, both for them and for you. And let's look at what that means over on the blackboard. So inside of our cloud environment, we have our workload. And that workload, in this instance, maybe we'll talk about it as a virtual server, but it could be any of the service models for cloud. And we've talked about how there's this management plane out here, and as part of that, we've talked already about the sort of the automation process and the automatable processes that sit inside of there that you can configure from a console typically, or APIs or command lines, as we spoke about before. And so what this measured service means is that whilst this is configuring what you have in here, there are a series of graphs or data points, more accurately, that are being kept and monitored by the cloud provider so that you can see what's happening. Now, some of these might be the amount that you spend, and of course that's a key one for the provider. They want to be able to tell you how much you're spending so that you can then pay. But you also want to know how much you're spending so potentially you can adjust your design and reduce the amount you're spending. Interestingly, Amazon Web Services actually provides you with tools inside of the platform as part of measured service to help you reduce your spend. It's quite an interesting concept for a business. Maybe more should take note. But this could also be processor utilization of, say, for example, this box. And we can use it, as we talked about. Remember, it was to monitor, control, and report. So we have report already in terms of dollars, and you can pull out other metrics so you can see it. And you can also monitor it, I guess, as well through that. So the reports can be for dollars, the monitoring can be so that you can actively see what's going on and ensure the health of what's happening. But you can control it as well. So you can set up metrics on these things to say, well, if my processor utilization has been over 90% or 80%, say, for 5 minutes, then I want my automation process to go and do something about that. Run something and go and do something. And so it might spin up another instance of the server, and it might spread the load across 2 servers. It might do that again and get you a fleet of servers all working hard because this is the busiest time of the day or the busiest time of the week, whatever the life cycle is for this application. And in the same way, this graph or this metric can be looked at and configured to say, well, if you're below 20% utilization across all of these boxes for more than 20 minutes, say, or whatever it might be, then turn some of these off because I don't need them anymore. So that's all about measuring a service so that you can actually then control what you're doing and actually using the automation processes inside of the platform to be able to look at those metrics and respond to it. It's also about reporting to you so that you can see what's going on and monitor what's going on. And of course, at the end of the day, bottom line, the provider wants to charge you as well. So in this section of the course, I'm going to talk about deployment models. And we'll go back to our NIST paper that we've been using all the way through this course, the National Institute of Standards and Technology, the definition guide that we've been using. And I'll go down to the last section now, which is deployment models. And we can see them there listed. And I'll just touch on them briefly and just sort of talk about them in general. There's private cloud, community cloud, public cloud, and hybrid cloud. And in a nutshell, this is really a procurement strategy for cloud. This is where you get your cloud from. Private cloud being infrastructure which is, it says it here, exclusive use. So a single organization has got its own private cloud. Now, I want you to remember the essential characteristics. You remember the essential characteristics of cloud where we had on-demand self-service, resource pooling, rapid elasticity. If you really want to be able to truly say that you have those, then a private cloud needs to be pretty big. So only fairly large organizations are likely to be able to have a private cloud. Community cloud then is where, I guess, a bunch of organizations can come together to form their own private community cloud. Public cloud is by far the most common cloud. So Amazon Web Services, Azure, Gmail, Salesforce, all of these things, pretty much most of these things we talk about are public cloud. And that is because you, a member of the public, you, a member of any organization anywhere in the world pretty much, can go and buy this. If you've got a credit card, you can rock up, you can buy it, you've got it. It's available to the public. Now that doesn't mean that the applications you store in there are then available to the public by default. Or of course they can be if that's what you want them to be. But if you want to have private applications and if you want to have private data, you can still use public cloud. So it's not about the applications or the architectures you deploy in the cloud environments. This is about procurement and how you buy them. And finally on the list there is hybrid cloud. And this, I guess, is talking about where you've got a number of these different types of deployment models and do you make use out of all of them. So again, by far the majority of providers that you'll come across are working in this space of public cloud. And that's okay. It doesn't mean that your stuff's out there for everybody to get. It just means that you can buy it and other people can buy it too. But remember, we talked about multi-tenanted environments in our resource pooling essential characteristics. So all of those other characteristics still apply. This is just as I said, a procurement model. And so I'll leave it at that. Pretty much everybody goes to public cloud. If you're lucky enough, I guess, to be in an organization where you can have private cloud, then you must be pretty big. And I got to say, you're probably going to be playing catch up to some of the public cloud providers if that's the case. But deployment models summarized there: private cloud, community cloud, public cloud, and then if you want a bit of everything, hybrid cloud. So that pretty much brings us to the end of our discussion of cloud, of looking at the terms and definitions which describe cloud. And I hope through this process and through this course that you've got a much better sense of the different characteristics and the service models that make up cloud. And let's have a bit of a recap. We talked about the service models. We talked about software as a service, where you go and consume typically a web application which is entirely managed by somebody else. We've talked about platform as a service, where we are deploying just the application and then everything else is managed by somebody else, and how these things are all really continuum which end off in infrastructure as a service. And so we had a continuum between the lot. Infrastructure as a service being where you get most control and you can deploy servers with your own applications and your own integration potentially, these types of things. So those were our service models that we discussed. We then talked about our 5 essential characteristics of the cloud. And if you're going through the NIST paper, this is the first thing they talk about. And we talked about on-demand self-service, so how everything's automated. And we talked about our person with the admin console who goes through to an automation process to be able to get their cloud resources. You know, they're not sitting there on the phone to Bob, and Bob's not on the phone to Sam, and it's not all a mass of people that are going around and doing stuff. It's all automated. I mean, in the background at Amazon Web Services, they have their own equivalent of Sam, but you never need to know they're there, and you never need to talk to them. And essentially, you never need to talk to an account manager, although no doubt they would like to talk to you from time to time. We talked about broad network access, how essentially you can connect to it through the internet, and that's pretty much all it is. Lots of people are going to tell you it's more complicated than that, but that's pretty much all it is. We talked about resource pooling, so the provider there masses together their economies of scale, so they've got an enormous pool of resources that can be sliced out just to you and to other people through a multi-tenanted model, so you get your own little slice of what they have to offer. But it's in a location which is independent of you, and you don't necessarily know where it is. You might be able to define it down to a region of the world, but that's all you need to know, and pretty much that's only for compliance purposes. So it's location independent. It's somewhere else. We talked about the other characteristic of rapid elasticity. So your application can scale up and scale down on demand. You only pay for what you use in that model. So if you scale up to 17 servers and you only use them for an hour, and then you scale back down to 1, then you only pay for those 17 servers for 1 hour, and then you're back to paying for 1 server. Back to this automation, back to on-demand self-service, I suppose, within that realm. And we talked finally in those essential characteristics about measured service. So you can see what's going on, the provider can see what's going on, they can bill you appropriately, but you can also use those metrics to control and maybe add into the automation process to be able to make use out of rapid elasticity, scale up and scale down based on not your ideas or what time of day it is, but how busy your application is. And finally, we talked about the deployment models. And we talked about primarily, I'm going to say, the difference between private cloud and public cloud. And here we go. We got our silk ropes, what are they? The velvet ropes, sorry, which is cordoning off our wonderful private cloud. You can't get to it unless you've got a special invitation. And here we go with our public cloud. And that's everyone can get in here. There's our signpost. That's what that's supposed to be. I'm getting towards the end of the course. I'm having fun here. And so you have the difference between our private and our public. And the difference is how you buy it. At the end of the day, the same kind of thing should be behind there, but in private, you only get to it if it's part of your organization. It's a procurement construct only. So that's it. That's the end of the course. I hope you've had I hope you've had fun. I hope you've taken away something from this course, and I hope it's been useful. I really would appreciate your feedback. Tell me what you liked. Tell me what you didn't like. I'm going to iterate through the style in which I put these presentations and videos and tutorials together. So please do tell other people, especially if they've got an interest in cloud, especially if you've had one of those conversations with them already where they're saying, there's no such thing as cloud, it's just a computer in someone else's data center. Well, now you know different, and now you have a way to respond to them. Tell them to come and see this course, and we'll put them right. So please leave some feedback, please leave me a review, and I look forward to seeing you in the next course.